All right, welcome back, everyone. Today we have Maha Achour. Maha is the founder and CEO and CTO of Metawave Corporation. She is a senior leader with more than 20 years experience in both public and entrepreneurial startup companies in the RF, wireless, optics, and networking industries. Previously, Maha served as co-founder and CTO of Raceband, where she commercialized the first metamaterial antennas and RF front-end subsystems for the cell phone and wireless LAN industries. She has also pioneered the first broadcast HD TV system over satellite, mmWave free space optical systems for last mile connectivity, and led various DARPA projects in wireless MIMO and optical devices. Interestingly, Maha was recently named one of the 15 top women in entrepreneurs, or 15 top women entrepreneurs in AI. And she has a very impressive background. I think, once we dig in, you'll see she's probably one of the 15 top entrepreneurs in AI in general. So thank you for joining us, Maha. We appreciate you spending some time with us today.
You're welcome. Thank you for having us.
No problem. No problem. So, I think your use case is very interesting. Historically, we've seen a lot of pure play software as it relates to AI. You have a bit of a different spin on how you're leveraging AI. Where I would love to start this conversation is to dig into a little bit into the industry you all are focused on, the types of customers you serve, and why they come to you to solve the pain points that they're having.
Well, I'm just going to start with the condition because we have an office also in Palo Alto.
Okay.
I just want to start with the conditions currently in the Bay Area, with all the ash from the fires and the fog and the poor visibility and conditions. And the question is that, how will the camera be impacted? How will the ADAS system be impacted in these environments, right? So at the end, you need a perception engine that is able to disseminate the objects surrounding the cars to, of course, for the safety of all, passengers and pedestrians and so forth. And most of the ADAS system that exists today or is available on vehicles today are mostly based on camera and LiDAR, very little on radar, if not at all. And the main reason is because radar is seen as a sensor for cruise control, for lane changing, but really not for perception. For perception, you need an imaging radar. You need a radar that has this high level of accuracy and resolution and range to be able to derive the perception around the car.
Okay, very helpful. So if we were to just back up a little bit, this radar, and the radar provides you that next level of perception, but the product you've built is is this purely for autonomous driving for all cars?
Well, the AI engine, which we refer to as AWARE, A-W-A-R-E, it's going to be targeted for level 4 and above, mainly because the level 2 plus really don't need to have that high level of perception.
Okay.
I'm talking about the consumer market.
So what is level 4? Can you help us distinguish between what level 2 is, level 4 is?
So level 2 is where the liability falls on the driver. So like the Tesla cars that they have today. You do have this autopilot, but at the end, you are in control. You have to follow what the car is doing and take over when mistakes are happening.
Okay.
Level 4 is what robotaxis are targeting, like what Waymo is doing, what Cruise is doing. They go and today, of course, they have a driver behind the driver's seat, but eventually they don't need that driver all the time. Be able to take control over the car, but they map all of the areas, the roads, so the car is quite familiar with those kind of surroundings. And of course, you have the level 5, where it's something that's not going to happen often decades from now, where you don't even have a steering wheel, you don't have accelerators or pedals, the car basically over the whole time.
It drives itself. Okay, so interesting. So I guess, in terms of autonomous driving, as we think about level 2, level 4, I guess generally, where are we today with this? I think, for the most part, I think I've even seen occasions where there's a car driving, there's no driver in the car, right?
Yeah, you can do that. Not today.
But so where are we actually today? Where are you all building towards? And I know there's this level 5 where you mentioned there's no steering wheel, there's no, there's nothing, there's just the car. Want to level set here to see where we are, and then where your software is actually integrating itself.
So when I started Metawave in 2017, the timeline was 2020, we'll get these robo-taxis on the car, full level 4 AV fleets. The reality hits, and basically, and of course, with the COVID factored in, there is a delay. And the delay probably will be in 2025, 2026. So we will see more robo-taxis on the road. But to get it to the consumer market, to the consumer ownership, that's I would say at least a decade from now, because the consumer market is quite different from the robotaxi or mobility as a service, and the main reason is driven by costs and also driven by the safety conditions.
Got it. And so when you say robo-taxi, now that is essentially Uber or Lyft or some type of service. I mean, I guess it could be whatever, but they have a car driving itself, or is there an actual driver in the car?
The idea, of course, is to eliminate the driver.
Right.
So you can have somebody there at the beginning just to make sure you get to the level 4, but eventually you do not need a driver in the car.
Okay, and then so level 4 is when Uber is saying, "Hey, listen, we don't need a driver. You'll be in there by yourself."
Well, you will have a driver in the driver's seat. It depends, of course, on the countries and on the legislations,
yes,
right?
Okay.
So I probably would guess in the first few years, like what Waymo and Cruise are doing, there is somebody behind the steering wheel.
Okay.
But actually, most of the driving is done by the car itself.
Okay. Got it. And then so where you all step in is and this is the aiWare or eyewear.
Aware, right.
Aware. Okay. And so Aware is essentially providing are you solving that security issue, that safety issue that folks are facing?
So you have a whole bunch of hardware sensors. The perception happens at the hardware level where the car senses its environment.
Okay.
And the radar is just one component of that suite of sensors and perception elements. And then you have what we call the sensor fusion, which is a software stack that is run on a high GPU system or a supercompute system in the car that analyzes these raw data and try to perceive the surrounding areas in order to decide what to do, assuming that there is no driver in the driver's seat, because the liability falls completely on the car itself and on the ADAS system.
That makes sense. And so where, you're not producing the sensors themselves, I imagine you're producing the software that plugs into the hardware that's in the car. So
Metawave is not a tier 1.
Okay.
So our customers could be the tier 1, sometimes even the tier 2. It's combining our solution with their solution.
Okay.
And the car OEM, the new kids on the block that are fully vertically integrated as well. So those are kind of our customers. But in order to demonstrate the capability of our imaging radar, platform, we had to build the full radar and demonstrate. And by doing that, we also had to build our own sensor fusion with the top LiDAR, the top camera, to train the radar. So as you know, the radar operates at one frequency, right?
Okay.
So the perception that it gets from its data, it's just based on that frequency. Now, if you leverage some of the deep neural network and build this machine learning platform using other sensors, when you collect the data, you collect the data from all the sensors. So what you're doing, you're training the radar with this other data to make the radar smarter. But once the radar is trained and the AWARE algorithm are defined, you do not need any input from these other sensors. So now the radar has the capability not only to detect the object. The radar doesn't have, the radar capability is not limited by just detecting and localizing the object and tracking them, but also enabling aware to label these objects. So the aware, role is to provide real-time labeling of these objects at long ranges and in all weather conditions.
Yes. And so I guess, folks who are using LiDAR, the traditional approach, the difference is that with aware, you're able to see further, able to label images in less kind of, to your point, if there's pollution, if there's dust, if there's fog, if there's, different situations where your LiDAR wouldn't be able to detect an image or an object. Radar, leveraging machine learning and object detection in machine learning, is able to step in and take it to that next level, which, creates a more safe autonomous driving environment.
Exactly. And those are kind of the tests that we ran last weekend in the Bay Area with the ashes, with the fog. And since we have a Blackmore LiDAR, which is the longest range LiDAR on the market before it was acquired by Aurora, we can clearly see the limitation of the LiDAR. Of course, the camera has always these deficiencies, but the radar was still up and running and AWARE was still able to detect these objects.
And can you talk a bit about training the actual algorithms? How did you acquire the data? Is it that you're going on these test runs with the car? Obviously, you had to build out your own hardware at first, but I'm more curious about that process to you're building machine learning algorithms. How do you get from point A to, all right, here we actually have a product?
Yeah, absolutely. Good question. And by the way, I am not an AI expert.
I
have a whole team of AI that did the whole thing. I'm just representing their work.
Yeah.
So as you know, our AI team mission is to enable algorithms like object detection using our custom radar, our imaging custom radar hardware. And in particular, we want to apply the deep learning mechanism because deep learning has made tremendous amount of progress in the past decades. However, there are three challenges we had to overcome. Challenge number one is that the limitation of the deep learning is that it's extremely data hungry, and it needs a lot of the label data, which is completely unrealistic and also very challenging when you are building the system for the radar. So if you are training something for camera on LiDAR, there is a lot of publicly available data sets that you can use and leverage. However, for the radar, there are none. So we're building the first kind of data sets. And then, of course, so we've decided basically to construct our own data sets and also build our complete sensor fusion. And our ground truth verification is done on a subset instead of on the whole data sets. So that's kind of the first challenge. The second challenge is that when we build the whole pipeline from the data set, data collection to the extraction of the AI algorithm, you need some sort of accuracy that you have to meet. And you can test the radar neural network, but the answer is that how do you get to that high level of accuracy in all kind of operating conditions? So that's another challenge that we had to overcome, and it's all by tweaking both the platform as well as the post-process data. And then the third challenge is that how do you really classify the object and how do you validate the classification? So this has to be done offline after data collection and on, as I mentioned, on a small subset sample of data, and it seems to be working. One thing Metawave has been keen from day one is to protect our innovation, since not only we are building the first steerable and scanning imaging radar, but also the first object classification platform based on a radar. So we filed many patents, and very happy to say that our first AI patent has been approved.
Awesome.
Great.
Congratulations on that.
Thank
Congratulations
you.
on that.
Thank you.
So you mentioned, just what you guys are building, right? It's very data hungry. And that there's a lot of data that needs to be labeled. That's common in machine learning. So I'm curious, did you all label that data in-house? Because it can be very expensive to do it. And, generally you don't want your your best data scientists or machine learning engineers or, whatever it may be in the organization doing that. So how did you face that? Curious about your process.
Absolutely. So we tried third-party labeling, but honestly, we decided to proceed and do it in-house. So we hired, interns, we hired junior engineers to do these other tasks as well. And the most important thing is you have to build a mechanism that streamlines not only the data collection and post-processing, but also the validation, the ground truth validation. And we have done this internally.
Okay. Any learning lessons you took away from outsourcing the data labeling, and then why the decision to do it in-house?
Well, most of the third parties' familiarities are with, especially camera perception, and to a certain extent the LiDAR. But on the radar side, very few have experience with radar, because if you take any radar on the market today, it doesn't give you anything. There is nothing you can interpret from the post-process data. And even if you take the raw data, you do not have the resolution and accuracy that enables the perception engine to discriminate between different objects and then classify them. So the fact that our radar is able to focus the beam in one direction, that's a huge benefit, and also be able to address interference down the road while steering the beam in the other direction is very critical.
Okay, very helpful. So it really comes down to you all have a very specific use case with it being radar, right? Yeah. So you needed to have folks who were trained on your team to be able to label things properly based on your niche, your use case. Okay, makes a lot of sense. And then you mentioned there's this level of accuracy, right? And I've got to imagine accuracy when, you're dealing with autonomous vehicles and all of the risks associated with it has to be pretty high. I'm curious, how do you determine what level of accuracy is proper to, present to potential customers that you work with to actually deploy the product to where we're actually able to use this in everyday life?
So typically cameras and LiDAR, they have to reach a very, very high number of accuracy because they are the main sensors today that are driving the EV capability in these robotaxis. And also because of their short range, mid-range capability. The car is almost ready to hit an object if the object is at 100 meters or 50 meters. So at these short ranges, you need extremely high level of accuracy.
Okay.
At longer ranges, you need just to alert the sensor fusion. So at 300 meters, if you see a car or you see a truck, or you see two cars close to each other on a highway, you have to alert the sensor fusion. So as the car gets closer, the sensor fusion can decide what to do, change lanes, slow down, accelerate, and so forth.
Okay.
And also for pedestrians, since our radar can detect pedestrian beyond 200 meters, it also can alert the other sensors. So now the LiDAR and the cameras, they really don't need to scan the whole field of view to detect those pedestrians. The radar already told them exactly where they are located, and then they just focus on this region as the car gets closer to them, and then get to the high level of accuracy. So it's a collaborative effort between all the sensors, with the radar being the first mechanism to detect and track this object, and leave the other responsibility to the sensor fusion using other higher accuracy and higher resolution sensors such as camera and LiDAR for short to mid-range. And I'll have to tell you, the speed at which the car has to react is extremely fast.
Mm-hmm.
So this is what we call typically the scan rate or the frame rate, because, you know, you need like a fraction of a second for the car to react. And if it takes the camera or the LiDAR a long time to scan or interpret the whole field of view, 120 degrees or 160 degrees, that's a lot of data to interpret. So not only the delay, but the power consumption. But if they can get some backdoor information from the radar, providing them with the regions of interest, instead of scanning the whole thing, not only they save power, but they also speed up the control process.
Yeah, that piece is very interesting, right? Because essentially you're saying, look, you don't have to scan the entire view. We can see further, you know, with radar than you can. We can detect objects further than what you're going to be able to do with LiDAR, right? So we'll tell you where to look. That saves on power consumption. Are there any metrics? So let's say when you're speaking to a customer, right? Are there any metrics that you can cite around power consumption? And then, you know, kind of the greater question I want to get at here is when you're speaking to customers, what's the kind of the ROI that you're saying, or is there an ROI that you're leveraging in these customer conversations?
So we're talking about level 4 here, because level 2 is all driven by cost.
Okay. Okay.
At the end, you can propose all kinds of cool stuff, but if you are, I would say, $1 up, it doesn't work.
And is that because of competition, or what's the dynamic there that's creating?
Well, it's just the profit margins are very slim.
Okay.
At the top of the chain, the car OEMs, right? And so all of this ripples down to the tier 2s and the tier 1s as well. But if you look at the robo-taxis, like you mentioned, the Uber and Lyfts and the Waymos and Cruise, safety is number one. I think you cannot put a price on human lives, right? All it takes is just one accident, and then the impact on that service will be tremendously impacted, right?
Mm-hmm.
So performance is always going to be number one, the highest priority. Give me what I need to get to the almost 99.999% safety.
Okay. And then,
go ahead.
Yeah, so it sounds like, if I'm thinking about this correctly, we can see 100 meters further than your current systems. That extra 100 meters is going to give you however many split seconds more for the vehicle to react, which in turn is going to increase your safety levels overall from X to X. I don't know if there's a way to mathematically put that together. It sounds like it's kind of just like, I understand conceptually what happens, but you know, I'm just curious the thought process that a buyer would go through if they're trying to evaluate the value that they get. You know, look, I understand. Let's say there was another company that did what you did, and they were trying to evaluate which vendor we should go with. Both are saying, look, they increase the safety level of the product that you're selling. Are there metrics that you can point to where you say, hey, you know, we can do it by X, and someone else is saying, well, we can do it by X? Or are we just not there yet, where this is just so new, they're just happy to say, look, I'm just happier that we can be more safe?
Yeah, so and I'll talk here about radar, right? Because each sensor is very different.
Okay.
As you know, the radar is driven by the top tier ones, the Continentals, the Bosches, the Densos of this world, right? And the OEMs, they are mandating much higher performance capability. And typically those tier ones, they buy these components from the tier twos, and the performance is basically limited by what they get from the tier twos. So the trend has been, what can I do on the software side? Since my tier twos are selling only a limited number of hardware capability that I can start with, what else I can do in the microcontroller that enables me to meet the OEM's performance? And the answer is, unfortunately, at this high frequency, Moore's law does not scale very well. Maybe it scales very well for the cell phone, luckily, but for this millimeter wave, it's extremely difficult because of the path loss, propagation loss. The signal dies very quickly. As soon as it leaves the radar, it dies very quickly, let alone to bounce back from an object and be detected is extremely challenging.
Mm-hmm.
So you need to add additional hardware component, and that's what Metawave is doing. It's building this additional piece of the puzzle, which is a hardware piece that enables these long range. So long range is a must.
Mm-hmm.
A radar that can only see 200 meters, in my opinion, probably is good for what's available today, but down the road, I'm talking about 5-10 years from now, it's not going to be enough.
Right.
So range is very critical. And range is only attainable if you add additional hardware pieces in your architecture. And then second, the resolution. That means if I have two cars driving on a freeway at 300 meters, how can I discriminate? Because most of the radars today, they will just see them as one blob, if they ever can see them at 300 meters. They cannot separate these two, so especially if they are driving at the same speed. So that's why what we call resolution is very critical. So, and then, of course, the accuracy, how precisely I can locate that car in the lane where it is. And also if there is a bridge above it, or if you are driving in a tunnel, how can I still see the car and not be blinded by all of the, tunnel, surroundings. So it's many factors. And I'm very happy to say is that so far we tested our radar in very challenging environment, including on trucks, because as you see, the truck is actually a very good example because AV trucks are very popular. And the problem with the trucks is that you have the trailer behind the engine. And typically those trailers have no sensors. You don't want to put any sensor, you don't want to put any equipment on it because these trailers are exchanged all the time. So you want to make the head of the truck as smart as possible with software and hardware. But how will the truck see behind? How will the truck know if there is a car behind that is trying to pass him or change lane? If it's driving without a driver, right? That's the whole point. So the real view sensing is very, very important. Okay. And the radars today, none of the radars can meet that because they are blinded by the side of the radars. Like the tunnel, you have the side of the trailer, which is most of the time metallic, basically blinds the radar. But our radar has been successfully integrated and tested.
Very interesting. So yeah, I mean, it sounds like the differentiator would be the level of difficulty, right? Or the level of accuracy with which you can identify certain objects. So, our technology allows us to identify more clearly, and with more accuracy, right? Okay.
That's right.
Interesting. So now I want to understand how you thought about, as you envisioned, right, Aware, how you thought about building a team to actually create this product, right? You mentioned you yourself, right? I'm not an AI expert. So as you have this vision, how did you know artificial intelligence would be a great use case for a product that you want to build? And then how did you go around getting those first people who were going to develop the technology?
So as an entrepreneur, and I have been an entrepreneur for quite a while, I have many scars, many lessons learned. And I love hardware because I always believe hardware is more complex, more difficult to solve than software. But the problem is if we're just selling that piece of hardware that enables our customers to do all this cool stuff, how can I maximize my return of investment? How can I maximize my potential revenue stream that is coming in? And for this, I have to think about what else can this little piece of Lego enable and build it, demonstrate it, not only to demonstrate the capability, but also to secure the IP. We could not, of course, just hire a vision-based AI engineer, computer scientist who are just based on, trained on cameras because it's a very different concept. So we hired, a very strong team that has multidisciplines and fully understand the raw data that are generated by our hardware, our radar, and they divorce themselves from what they know about the camera and LiDAR. They just pick and choose the different pieces that we can leverage, but we had to build the whole thing ground up. And you really don't need a very, very large team to get to that point. What is the most challenging, in my opinion, is building these multidisciplinary groups from the IC development, integrated circuit development, all the way up to AI, and how you get them to collaborate together, to work together towards such a common goal. That is the most challenging part.
Yes.
And I think with corporations, they don't have, this kind of thinking, because they typically have hundreds of AIs, hundreds of hardware, and it's extremely difficult for them to sit down and work together. And that's where startups excel.
Yes, yes. So very interesting, because, you don't just have a team of AI engineers and you stick them in a corner and you say, hey, go do your thing, right?
No.
It's a lot of collaboration. Can you talk about some of the ways or talk about how that looked, right? Meshing these teams so that you can leverage these multiple disciplines to ultimately produce what you produce. So did you have a small pod of 5 folks with different skill sets, or, how did that look?
Well, you just build them. You have to start with the missing piece first, right?
Okay.
The hardware piece that is missing. And as you gradually build, and in parallel, you have to get the AI team to develop, the algorithm or this platform, the machine learning platform, based on some assumption that is coming from the hardware. So you have to do everything in parallel, because a startup, we don't have the same leverage as big corporation. Mm-hmm. Every single month, every single year, we have to meet many milestones. We cannot do things serially. They have to be done in parallel. Mm-hmm. So the most challenging part is, how do you make the adaptive communication between the hardware team, the system team, and the AI team? Mm-hmm. So they have kind of the 3 different pillars in building our line of products. But it's done by continuous meetings, continuous collaboration, and thanks to technologies, because our AI team is based in the Bay Area, our hardware, software, and system team are based here in San Diego. We have 2 vans running here and up in the Bay Area to collect data and to optimize these kind of performances. So I said, it's just, you need to select the right people. Mm-hmm. I always love to quote Steve Jobs when he said, your core team, your A+ team, needs to be able to deliver results without requiring micromanagement or higher management. They are self-disciplined, self-managed, and they have no problem managing other people if it's required. Because as long as you lay down the vision, everybody is basically charged to meet these goals.
Yeah, and one of the things I think is interesting, which you alluded to, is your AI team, right? They have a specific skill set related to AI, whether it's building algorithms, even if you take it, something off the shelf, and you start with that, right? But there's also a place for a subject matter expert, right? The subject matter experts has to come in with a level of knowledge in that industry to be able to inform what the AI team is doing. And without that collaboration, you're ultimately not able to build a product intelligent enough, especially somewhere with the accuracy that you need. You're not able to build something intelligent enough for you to have a market-ready product.
And especially when you have a highly customizable radar, a radar that you can configure it in any way you want for any application you want. And it's highly adaptive as well. So it gives them a very flexible platform to work with, which means a lot of work to get it to meet the high level of accuracy in all operating conditions.
Yeah. Now, as you think back to, because, in my experience, one of the things, especially with startups, is that if they're doing well, right, assuming they're doing well, scaling your talent is one of the most pressing needs. So, would love to get more perspective from you as a startup. How did you approach finding the right talent, right? You mentioned you couldn't just take someone with, a skill set in computer vision, right? So how do you find those people those people with the combination of skill sets you need. What were there any levers that you were able to leverage to get them interested and say, hey, look, I would love to work with you?
Yeah, well, a lot of referrals from our team. As you know, we have many PhDs. They have a lot of connections, and LinkedIn has been a great platform for us also to connect with talent directly. The most successful approach that we have in place is to have 3 levels of screening. First, by just reviewing the resumes, then having 1 phone call with the candidate, and then we have a full day interview process where everybody needs to give thumbs up. Having said that, we only scale when we need to hire more people. So as a startup, we still have to operate in a very lean, conditions, because just scaling for the sake of scaling for startup is counterproductive.
Right, right. Any challenges you ran into related to finding the right person? Right? I imagine there's this gap between, all right, well, here's a person who's available, but here's the person who actually fits, right? But I'm curious if there's anything specifically where, hey, here's a challenge that we face, here's how we overcame.
Yes, of course. But there are always alternative ways to still make progress while you are searching for the right candidates. At the beginning, when you're building your core team, is very, very critical to have experienced, dedicated, teamwork, attitude candidates. But we also rely on experts to help us fill these gaps until we have these additional hires in place. So the hiring process never slowed us down.
Got it. So it was, and if I'm understanding correctly, it's, maybe we bring on an expert to fill the gap, right, on a temporary basis until we actually have that person that we can bring in on a permanent basis for the business. Okay. Yeah, very interesting. Very interesting. So I know we're kind of coming up on time here, but I want you to reflect, going back to day one. If you could, knowing everything you know now, if you could start over from that day, are there any changes you would make? What would the first 90 days look like for you?
That's kind of an interesting question, because you learn, during these times you learn. If you really don't make these mistakes, you're never going to be put or placed on the right path.
Right.
I've done the same thing when you have changed anything, right?
Yeah.
So it's the journey, in my opinion, that leads you to success, and not the shortcuts. Okay.
Yeah, absolutely. And I guess maybe another way to put it would be to say, if you could hire yourself as an advisor for free, right? What could that advisor to tell you to get up the curve faster, right? Are there any, experiments you tried where you're like, oh, we tried to do it this way, but actually we needed to kind of deviate?
Yeah, it's a good question, because in my opinion, hype is something you really cannot identify early on. And I would say in 2015, 2016, 2017, the AV industry was on its trajectory to hypes,
Right.
So, and riding the hype for a startup is very different from riding a hype as an established big company. So I think that's kind of the only kind of lessons I will inform the other entrepreneurs or other CEOs. If you're going after a market that is new, that is evolving, but it's very hard to distinguish between those two, right? The same thing during the bubble, 2000 bubble, when everybody was over the hype that gigabit speed is allowed, and all of these fiber equipment, optical equipment have accelerated, and it turned out to be a complete bubble. So, but there are a lot of new opportunities, like the cell phone, like the wireless connectivities, that happen, and they weren't hype. So it's very hard to discriminate between what is real and what is a hype phase. So you know exactly how to position your roadmap.
Yeah, I would co-sign that. I think even in the, everyone, especially in my investor days, there were, essentially everyone said, hey, look, we have artificial intelligence, or it's on our roadmap to build. But when you're actually in the industry and you understand, well, but who is putting forward, dollars to actually build out the technology, right? Same thing, autonomous vehicles. Everyone wants it. We all think it's a great idea. But if you're a vendor into that industry, there's a big difference between who thinks it's cool, who would love to have it, and who is like, look, we are ready to move forward and write a check because we love your product, right?
Yeah, exactly.
Awesome. Well, thanks for joining us today, Maha. This was very helpful, very interesting, and we appreciate you spending some time and enlightening us on what you all are doing over at Metawave.
My pleasure. Thanks for having me.